When a rope is moved up and down, a series of pulses travel down the rope in the form of a wave. Each part of the rope has been given energy and it moves up and down. But note that the rope is not carried along with the wave pulses, rather it is the energy that is transferred along the rope. And that's the first key point for this lesson, is that waves transfer energy from one place to another. A wave in a rope is called a mechanical wave. Mechanical waves disturb the material they pass through. The particles in the rope are being disturbed, and they are moving up and down or oscillating, which means going up and then down in a repeating motion. The oscillating particles transfer energy to each other, and the energy is passed down the rope. This is an example of a transverse wave. Particles in the rope oscillate at right angles to the direction the wave energy is travelling in. An example of a transverse wave is a water wave. A falling drip from a tap disturbs the water and causes the water to move up and down. This in turn moves nearby water up and down, so energy from the falling drip is transferred along the water. Note that the up and down movement of the water and the direction of the transfer of energy are at right angles to each other. That's the definition of a transverse wave. A sound wave is a mechanical wave caused by vibration of an object, which in turn vibrates the nearby air molecules. The energy of the vibrating object, a speaker in this case, is transferred through the air molecules. Notice that the air molecules move back and forth, parallel to the direction of travel of the energy. Such a wave is called a longitudinal wave. So there are two kinds of mechanical waves. One is transverse, and in this case the wave moves particles up and down, and the energy from the wave is transferred perpendicular to the particle's motion. An example of a transverse wave is a water wave. The other kind of mechanical wave is a longitudinal wave. The wave moves particles back and forth this time. There are areas of compression and there's areas of what we call rarefaction. The energy is transferred parallel to particles in motion. An example of a longitudinal wave is a sound wave.